Hello, everybody. Thank you for being here. We're just going to wait for a couple of minutes to let everybody trickle in. We have a Q&A button at the bottom. Feel free to share any of your thoughts, ask your questions as the webinar continues to go. We'll be asking Bryant as many questions as possible today. Just to let everybody trickle in for the first handful of minutes, we're going to start with Bryant's thoughts on GPT-5, which was supposed to make a splash last week, but didn't necessarily do that. Bryant, what are your thoughts on this?
Well, I think it did make a splash. It wasn't maybe a nice, clean, clear water splash. It's more like a splat in the mud. But so you probably all know or have heard of this thing called the Gartner hype cycle. It's not something you ride, but Gartner is a marketing firm. They're very well respected. And years ago, they had articulated a a pattern that new technologies, particularly automation technologies, go through after they're first released. And it starts with some kind of trigger event, and then it's whoever brings it out, starts hyping it as the greatest thing, and everybody gets really excited, and sometimes it goes viral, and you have this upward curve of excitement and hype and expectations. And of course, in this case, we know the trigger event that happened with chatbots was when Chat GPT was released. Excuse me, going on 2 years ago now, and its uptake was the uptake of a new technology. And the hype is going up and up and up and up. And the hype has been, this is a major step forward to the creation of artificial general intelligence, AGI, which I'm sure everybody in this group has heard of because you're all interested in AI, obviously. But I remember when that term was invented. It used to be called AI, and then there were so many people who created stuff they called AI, but never turned out to be AI that they needed a new term for that. And so they called it narrow AI, and then the real AI everybody was looking for was called AGI. So the hype has been that we were on the road to AGI. And so the Gartner hype cycle says you reach up to a peak of inflated expectations, and then you start going down again, and people become disillusioned, and you go down, 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 and finally you hit what they call the trough of disillusionment. And then, but the technology is still there, and people start figuring out how to use it again, and it starts, there's the plateau, no, the slope of enlightenment, meaning people find out what it's really good for and what it really isn't good for. After the hype is gone, the disillusionment fades, throw the bolt behind you, everybody can sit down and actually find out what it's good for. And finally, it levels out into the plateau of productivity, means is it a tool that actually makes things more productive? Well, I think as of this week, with the release of ChatGPT-5, we have hit the peak of inflated expectations, and we're now about to enter the period of the long slope down to the trough of disillusionment. So that should be very interesting to see. We couldn't predict when it would peak, but really, this is a very clear signal, because just last week, Sam Altman at OpenAI was putting up memes of the Death Star rising over a planet. This is ChatGPT-5. ChatGPT-5 is huge, it's big, it's going to take over the world, it's going to be the biggest thing ever. And he was talking about human level, superhuman level, PhD level knowledge and productivity in this thing. And so it came out, and everybody goes, what? I say everybody, but if you look at the articles, I see 20 AI articles a day, and I had never seen so many negative articles come out about any LLM type thing ever since we got on this merry-go-round with ChatGPT in the first place. I've never seen so many disappointed and negative articles. Disillusionment is thick today. No surprise to us, of course. We knew it was never going to be AGI because we've been pioneering our own science of intelligence and knowledge, and stringing words together statistically. A parrot is not intelligent, not in any sense. It's not a big step forward. It's not a step forward to anything other than an interesting tool for generating text that you might find or may not find useful, but there's no intelligence there. There's no knowledge. There's no mind. And we knew that from the very beginning. No surprise.
Well, I do want to thank everybody for being here. Again, this webinar is going to be recorded and sent out, so if you do have to leave before the top of the hour, it's no problem at all. We'll make sure to send that recording over. This is actually the second Father of AI in Space webinar that we're doing, as you all should know from the marketing. But if you didn't know, Bryant is the father of AI in space. He can say more about that today. He's still coming to terms with that moniker, but we're going to make sure that he is as comfortable as possible with that because it's true. Bryant, we would love it if you share your story, how you got to New Sapiens, other companies you've built, um, and how you got the term Father of AI in Space, other than your marketing department.
Well, our small but very enthusiastic marketing department came up with that term, and I do confess I wince a little bit. Me, Billy, I didn't set out to be the father of anything. I was just trying to solve a really hard problem, and that was the problem of um, space operations. I've talked about this before, but I came from a naval aviation background where I flew big complicated airplanes around with a crew, and we had a cockpit that gave us the information we needed to fly the airplane. It told us right now what we needed to know in a very carefully laid out cockpit. So we didn't have to be thinking about making real-time conversions of measurements of temperatures and things like that in our heads to figure out what the aircraft was doing. And so I had come to the Hubble Space Telescope mission operations contract. That is we were the group that was tasked to fly the spacecraft. So I immediately saw the Hubble as like a remotely piloted vehicle, and the mission operations control center was essentially the cockpit. And that is exactly, by the way, corresponding to where they fly these big drones that go all over the world, the big ones. They have basically what is a remote cockpit, and they fly them just like an airplane, but remotely. So that's how I saw Hubble. But when I looked at how they were doing it, they had these tabular displays. That is, imagine a table, like a spreadsheet with rows of mnemonics and beside them numbers, and these numbers were changing, and those were measurements of things like coming down the spacecraft, like battery voltage and battery temperature and relay position this way and solar relay drive electronics, basically just as numbers. So I'm thinking numbers. I have to convert those numbers in real time because they're changing once a second. They're updating 28.2, 28.1, 28.3, battery voltage. I'm trying to keep track of the whole vehicle. And I thought, well, if I had a display like that in the airplane, I'd be dead. You couldn't fly an airplane like that. So I thought, well, what we need to get the computers to convert those numbers into and give us a display that we can react to. And on a computer screen later, that became in what in aviation was known as a glass cockpit, but they used computer displays with color graphics displays to tell you what the airplane was doing. And I wanted that for spacecraft, and that became my mission. So, but I saw it as I knew what the numbers meant, but people are good about taking that many numbers in that real time. So I thought, well, how can we get our knowledge, the knowledge of our trained operators who studied all these parameters, and get that knowledge into a computer program that could keep up with the data and convert it, kind of the same reasoning process that humans go through, and display it on a glass cockpit display. So instead of having, maybe 8 people in the room or 10 people in the room, or in the case of the space station, which is 80,000 parameters with 200 people in the room, just 1 or 2 pilots, like a pilot and a co-pilot, maybe most. So that became a mission. And this was a long time ago, but at the time, AI has changed over the years. What we called AI then is not what we call AI now. And it's not what we call AI at New Sapiens, which is the third thing altogether. But in those days, it was expert systems, and that was a matter of writing rules. And I thought, well, I could write rules and without having to know programming because there was a tool you could get. And Lockheed, my employer, had an expert system shell. So I created an expert system, and that was the first time anybody had taken an AI technique known as AI and applied it to spacecraft operations. So in that sense, this was on the ground system, so I wasn't really AI in space that like it was on the Hubble Space Telescope, but it was in the loop of operating the telescope in the control center. Now, this first thing I did wasn't really a real-time thing, um, because the systems weren't fast enough to analyze real-time telemetry. So what I was applying it to was a computer dump of the onboard computer down from the vehicle to the control center, put my through my expert system, and the computer dump for the onboard computer status registers was basically just ones and zeros. But this expert system reasoned about it by mimicking human reasoned if then else type logic, but the data was embedded in the rules, which was ultimately its Achilles heel. But it worked, and it could analyze what was going on with the onboard computer in about 15 minutes. But it would have taken a trained analyst, myself, maybe an hour and a half to go through one bit at a time. I mean, literally one bit at a time. 0101. Well, that's hex H character that corresponds to look it up in the so very time consuming. So that was the first time AI was ever used in a space operations thing. But it wasn't going to get me where I needed to go because um, it wasn't fast enough. I wanted that real-time telemetry link. But I showed NASA what I had done, and they were, giving me a pat on the back. That's great, Brian. That's cool. We're going to send you out to the Lockheed AI Center residency program for 6 months and get you equivalent to a master's in AI. And then you can come back here and continue this great work that you're doing. So, wow, what a deal. That was a great deal. And so I went out to Lockheed AI Center, and it was in Palo Alto, right up on Sand Hill Road, where the VCs are. But up the bottom of the hill, we had Stanford, and so the Lockheed brought the Stanford AI people up to give us 3 months of 5 hours a day or 8 hours a day, whatever it was, classroom, and then we had 3 months of practicum, and it probably was equivalent to a master's degree. And the Stanford folks were saying, "Yeah, this is how the brain works. You have all these rules. You're not conscious of them, but you're applying these rules to reason about things, and that's the essence of human intelligence." Well, even then, I was skeptical that that was really AI. I remember one time sitting in the control center and watching a pattern of telemetry, numbers there, and it was bouncing around, and everybody was saying, "Oh my God, the system's unstable. We got a electronic battery failure or physical failure." And I said, "No, that's voltage. Voltage can't transit that fast. It's got to be a sensor error." And I realized I wasn't really reasoning about it so much as recognizing a pattern that didn't fit with reality. And that intelligence wasn't just one thing like reasoning. It was a whole bunch of different skills, which meant that probably expert systems weren't really AI at all, although that was maybe a part that could be AI. But anyway, when I was there, went out and built a real-time shell. Like I was kind of the mover behind some AI scientists out there to create a expert system shell that would keep up with real-time telemetry. And we built it, and we was excited about that, but um, not much was being done about it. So we jumped out about Lockheed. We founded a company called Telarian to market it, and we asked Lockheed if they would give us the technology we had developed because they weren't using it. And they said, not only no, but hell no. And then everybody lawyered up, and but the funny thing was, eventually they gave it to us, not gave it to us, but we had to pay them back royalties for their development costs from the company's operation over a period of years. And the reason he did that was the people inside and the customers at NASA and Lockheed said, give it to them. Because, these big bureaucratic operations like NASA and Lockheed are never going to get it on the floor. So we commercialized it. But you know what? After a year and a half, um, it was clear that you were going to need too many rules, and it was too hard to maintain them, and it didn't scale well. And I didn't understand why for quite a while, but eventually looking back, it was a failure of epistemology. It wasn't knowledge, it was just reasoning. It was mimicking human reasoning, but you were embedding the thing you were reasoning about in the code itself. And knowledge isn't just a bunch of rules. Each rule was basically one assertion. That's data. And there was no organizing principle of the data except one, inference. A implies B. So it was really a philosophical failure or a scientific failure of understanding what knowledge was. So looking back, it was the first time anybody applied what was considered to be AI on spacecraft. But in my mind, it still wasn't really AI because it wasn't really what I was coming to understand intelligence to be, which was a bunch of a collection of different skills like pattern matching and reasoning, memory management, which processed something outside of it, which was knowledge, which was a kind of a unique information structure. And in my second company, we kind of figured that out. We realized that we could take an engineer's knowledge of the spacecraft, space systems engineers like myself, who think about systems like that as being state machines, systems which have subsystems. Each system has a number of discrete states that it can be in any given time. Only can be one state at a time. It traverses between a collection of different states on a defined state topology. And the states of a system is determined by the states of its subsystems, and so on down to the lowest level, where the state of a component, where the lowest level subsystem can be recognized by looking at a pattern of predefined values of its incoming telemetry thing. So one of the fundamental breakthroughs was that we realized we could write an intermediate markup language, which wasn't programming. It was a way for the engineer to specify systems and states and their relationships. And then we put that into this intermediate markup language, like if you know what XML is, it wasn't XML, and then we could write a computer program to process that and turn it into an independent object structure in computer memory. But the unique thing about this structure was it still looked like the knowledge that was in the engineer's mind. And if you went in your mind and said, well, the Hubble Space Telescope has 6 batteries, and I have the ID for battery 6, I could go to the program and there was battery 6. And it had an array of properties, which were just like the array of properties of the battery in my mind. It had the same, and the states, again, that I understood it to have in reality were, again, you could maps directly over. They were now compiled into this object structure. So for the first time, you had a direct one-to-one correspondence between a concept or an idea and a human mind and all its properties and relationships. And those same things were in the computer memory, but in a different fundamental storage format, but that was irrelevant. I mean, I don't know how the human brain neural network stores this stuff. Do you understand how computers work, though? So we understood how the computer stored it. That, in my mind, for the first time, we had a computer that had knowledge, that was a static structure, it was an object structure, it was put in at runtime, and then it reasoned about that on the basis of incoming telemetry. And it was just an amazing thing. It really worked. And that was now about 1994. That, in my mind, was the first time AI was applied to space operations. But by the way we think, that's the first AI ever that really deserves the name of AI. If you define intelligence to mean something which is basically the same in a human mind and in a machine, which is the intelligence part is the processing routines, pattern matching, inference, logic, memory management, processing a independent information structure that is a model of reality, and that it has all the little bits of data that we say reality have all the attributes, properties, all arranged in a very carefully constructed arrangement structure, information structure, which you can then query to get accurate and efficient information about the real world and act upon it in an accurate, efficient way, which was the goal I was after. And we were able to then retrieve that information. We could take the telemetry values, looking at every parameter, every sample, and see how the whole spacecraft, the whole state machine was responding, um, and put those beautiful colored glass cockpit displays in the control center. And instead of having dozens of people, we could have done it with one. And it was really, I think, the first true artificial intelligence. And you could make the case that qualitatively it was a general intelligence, and that the knowledge of the spacecraft was there to be applied and reapplied and seen from different perspectives. And it was insofar as knowledge is something that technical could be general. But now, of course, by general, we mean something even broader, which we mean like general in the sense of common sense knowledge of the world. In fact, this technology we've developed, which stores information in a way that we build larger and larger structures, and the way they can connect and disconnect, the way things in the real world act and react to one another, that it's already a general intelligence. That information is general and reusable in every sense. It's not at the level, if you define artificial general intelligence at the level of human performance, our sapiens aren't at the level of a college graduate or even a first grader, but I think it's still in that sense of being qualitatively, AGI is here now. And quantitatively, at performance level, I think it'll come rapidly as we finish building out our model and start to add the other routines. And another amazing thing, which I think if you've seen some of our recent demonstrations, you say, well, there's so many ideas, so many things, even if it's general and compact, isn't it a huge amount of work? Well, insofar as humans learn through language, it's already an incredible learning machine, because as we've demonstrated, it's got an amazing ability to infer, to create new ideas based on the ideas it already has, like when you put something in a sentence. And we've demonstrated that if I say that cranes catch fish by the shore, and it doesn't know what a crane is, but the fact that it's catching fish, it can immediately infer that at least it's an animal. And then if I say it has a beak and feathers, the only animal can have a beak and feathers is a bird, so now it knows it's a bird, and you never told it was a bird. And once you know it's a bird, then it inherits all the properties of birds. So every time a person, if you have a conversation with a sapiens, and if it starts out with 3,000 concepts that are built into it, by the time you talk with it 20 minutes, it's probably learned another 15 just by talking about it, and quite accurately too. So just like humans, they say a college graduate has 30,000 concepts in their minds based on a rough correspondence between that and their vocabulary. Only a tiny fraction of those concepts came from, being taught explicitly, looking up in a dictionary, reading something about an encyclopedia, or even sitting in a classroom lecture. The vast number of those came from just inferring what they must be based on the other ideas that they're connected to in language. So in that sense, I think the first true AI in space was really in the 90s. We applied it to the Conestoga launch control system, and the couple of satellite constellations, for which we had incredible performance gains in those systems. So that's kind of how AU justifies calling me the father of AI in space. I'm certainly old enough.
And you're certainly more experienced enough. Thank you so much for that background, Bryant. We really, appreciate that and commend you for having that experience and also applying it in this day and age when AI is so widespread, but also so necessary with everything that's going on with generative AI going down. This is a time for an AI exactly like this to, take over. So let's turn to the AMA section. Everyone, you can add your questions in the Q&A and we'll answer as many as possible. We have some loaded up already. An anonymous attendee asks, can you discuss the current status of New Sapiens right now? Some investors want an update. Where are we at? Where is Companion Sapiens? What are we doing at the moment?
But right now, we have expanded over the last year from about 5 to 15 employees, with 10 full-time SIEs, synthetic intelligence engineers, that have just gone through training and are now working on building out the model very, very diligently. Building out, that's, maybe you've heard me in the past describe, we've already sketched out that core common sense world model, which is the foundation for cognitive learning through language, which is the fundamental capability we'll build our first products on. So in that sense, the technology is ready today for a platform. And the first a platform is something you build a product on. A platform is something you build many products on. The first product we're building, we're building a number of products of our own, and we're also in talks with other companies to build products on our platform. We've got a letter of intent signed in with the group in healthcare. We're negotiating another letter of intent in cybersecurity. A very promising meeting today in that sense. In terms of the first products, we are focusing in. We've always talked about the companion, but the companion, of course, is a platform for lots of um, more narrowly focused applications. And some of those apps we maybe find that may be commercially viable, even alone without the full-blown knowledge comprehension that we're shooting for with the companion sapiens. And we're articulating what some of those might be like. For instance, if we just did one that was just really nailed the issue of helping you manage your medications, we can already do that. I mean, it just needs to be built out and be able to add some, additional things. Like, for instance, you'd like to be able to say, well, how many times did I take metformin this month, or how many times did I miss it? So we could focus on that. There are all kinds of pill minder apps out there already, but nobody likes them. They're a pain to use, and they don't go very far. Another one is just the reminder type thing, is smart reminder. Of course, pill minder would be part of that too. Another one though is like the Where Things Are app, and that would be incredibly good for doing inventories and in boxes, or where everything in your house is, just by saying, well, I'm looking at this drawer here or my toolbox, and here's what's in it. And then later you say, where's that yellow-handed screwdriver? And it come right out and tell you, well, it's in the toolbox on the shelf in the garage. I would love that. Or when you're moving, can you imagine? And those things are very reachable to us in the nearer term. I'm talking, we could have something like that fielded within 12 months. So it's been a long road, but we're getting close. I think the timing is better and better. We really are making progress in the technology right now. We know how to do it, and we're building it out. The biggest challenge has always been, because we're so contrarian and because the financial sources of seed capital have been, everybody's been chasing LLMs, of course, and all that hype out there, and billions have gone into it. So we've had to struggle. We've raised, up until now, about $8 million. We did 3 rounds with accredited investors and raised maybe $2.5 million. And we did a 1.1 million crowdfunding. Then we did a 2.5 million crowdfunding. And we have a crowdfunding going on right now. And so we can raise another 2.5 million for within 12 months of the last 2.5 million we raised. You can only raise on crowdfunding 5 million a year. And we are getting some traction of that. I think Ayush will mention that to you at the end here. We're also beginning to talk to some institutions and financial organizations that could put in much bigger money. I believe that we will probably raise another 5 million from those sources before the end of this year. And that will cause us to accelerate even more, probably double our staff and accelerate things. It'll also give us more money to support additional crowdfunding. We need to do that. So I think we're finally solving the funding difficulties we have. And of course, we need your help to do that. But the future looks very bright for us right now. I think that when we come out with those first products, if you combine the fact that we will be seeing really solving some of these, the first truly artificial general intelligence, first true language comprehension really does understand what you're telling it. And when we can understand language, we have a continuously updating context model. So the thing about language, people think that words have a meaning, and they always think that one word, one meaning, but that's not the case. Words have multiple meanings depending on different contexts and in different combinations. And what it really boils down to is, what's the reality? Can you find the reality of the ideas in the mind of the sapiens or the mind of the human that you're really trying to talk about and communicate over? And once you've got those ideas, they only go together in certain ways because that's reality. If you're catching fish, you've got to be an animal in the sense of hunting fish. You can make that inference because that's how the world works. That's what that means. So we solved that problem. So that's kind of the general state. It's never been more exciting. And I also see the opportunities we're changing. There's some new regulations have changed. I think it's even going to be likely that within a year, we'll have secondary marketing instruments such that our investors will be able to have a market that they could get liquidity in their shares without us having to do an IPO. That's kind of cool, and I'm pretty sure that's coming as well. So I gave you, I hope, a thumbnail of the company from a technical standpoint and from finance and from growth and future plans. So I'm happy to answer more specific questions about that or any of those things.
We're going to take just a little bit of a detour and discuss our cognitive core. So another anonymous attendee asks, can we discuss the differences between the structure of the ontology that the old SICK project, which was symbolic AI, built, and our cognitive core structures?
Yes. Psych, CYC, down at, I think it was Austin, 40-year program to build an expert system, one rule at a time. Now, that's the same technology I first applied to Hubble and found that it didn't scale. But they want the aim of the site was to create an expert system that basically had common sense. Okay. So that's knowledge of what we have distilled down to about 3,000 individual concepts about everyday things, actions, and things that do actions and results and quantities and qualities. But they're doing it one rule at a time. Anything you could say about something had to have a rule to capture that. And they wailed away at it for about 40 years. I think Doug Flynn, was that the guy? Not sure. I think he recently passed, fortunately. But they kept working at it. And after 40 years, they think they had over 1 million individual rules or assertions, I think. But they estimated they were like 2% done. Hopeless. It's a hopeless way to go about it. They didn't have any concept of epistemology in the way we have. Every concept that we have has like 4 or 5 different, certainly 3, depending what 4 dimensionalities that are things that are not what is even in there. These are things that what we call items of thought or parts of our cognitive core, the fundamental cognitive building blocks. Psych didn't have any notion of fundamental cognitive building blocks. Now, do human beings have that in their brains? Undoubtedly they do, but it's really vague to understand what's going on in the mind. But we've got to them by taking an idea that we deal with every day, like tree or person, I think breaking it down into its components and smaller parts and component ideas, qualities and quantities and all the things, and smaller until you get to the point where you can't break something down any further. That's the cognitive core, a collection of essentially the atoms of thought. And we call it the core, or we call it like a schema, but it is in total. And then if you consider the relationships and what the software knows to do with these pieces as it builds up the more complex structure, um, it's essentially like chemistry. All the material complexity of the world, 102 atoms, which can only connect in certain ways. And you can predict how they're going to connect because they've been arranged in a multidimensional structure called it's only a two-dimensional structure, but it's called the periodic table of the elements. But that tells you, because of where they are in that structure, that argon and neon won't combine, but sodium and chloride will readily combine. So you can predict how things can connect together to make more complex materials. We did the same thing, how things can connect together to make more complex ideas, which in the end also have that kind of integrity and coherence. And eventually you get to the point where they practically self-assemble, like the case of the system understanding a crane has to be a bird, because A fits the pitch, so it must be an animal, and B has beak and feathers, therefore it must be a bird. And that's just like chemistry, because it only fits together that way. Psych had no notion of that. Everything you wanted to say at Psych, you had to specify a rule. So, fundamentally different. Our structure, the data structure itself, is normally called what mathematical follows. So math has some mathematical properties of a directed graph, which you can visualize as nodes connected with other nodes. Looks like looks like a molecular model. It's just like a molecule, like a molecular model, not a real molecule, because we don't know what they look like, but it's a model. And so it's very compacted. And so our quote chemistry, the actual numbers of I don't know the actual number, but it's on the same order of magnitude, about 100. Instead of having two dimensions like the periodic table, we have probably 4 dimensions, and there's 1 or 2 other possible ones we might also dimensionalize. We mean by dimension a epistemological or ontological property that every single concept in it is classified by or organized by. So it's very powerful, very complex, and very compact.
David Chevront, happy that you're here with us, David, asked, since we mentioned the large number of controllers currently required to operate the ISS, how do we see the feasibility to apply AI to reduce ISS operational costs if there were an opportunity for commercial operators to upgrade the ISS to extend its planned life?
You might not like my answer. Commercial would be the key there. What happened back at my last company, Altair Aerospace, when we had solved the problem of satellite control and could reduce any control center down to a pilot and a co-pilot? Why didn't that happen? We solved the problem technically. The problem was the market, and we were doing really well in the commercial market area. There was a commercial space community going on. We had the big contracts we got with Conestoga, which was funded by NASA, but it was a commercial company, ER Systems. And then we did another one for a commercial satellite constellation called Final Analysis. We monitored a spacecraft constellation. But the biggest thing going down, there are 3 big things happening in commercial space. One was Iridium, one was Globalstar, which were direct Earth to satellite phone systems, and Teledesic, which was in the planning stages, which was going to put a constellation of 700 communication satellites in low Earth orbit, essentially broadband internet. Essentially, it was what Starlink is today. And we got the contract to build their whole control system for Teledesic. Not only that, but everybody was building space spaceports to launch all these 700 satellites. Canada was building one, New Mexico building one. There was like, 7 or 8 of these things, and we were picking up the contracts to build control systems for those as well. So we were doing really well. And then something happened. It turned out that both Globalstar and Iridium went spectacularly bankrupt because they missed their market to cell phones. So when they got their satellites up there and they had these, it was working, but the telephone was as big as a brick and it cost $5 to make a call. And any place where there was actually customers, they could use their little cell phones, Motorola flip phones. And the only place where you really needed it, because you didn't have cell phones, was in the middle of the ocean or in Antarctica, and there's no customers. Boom. And when that happened, all of the investment in commercial space just evaporated overnight. And teledesic never happened. All the spaceports didn't happen or were delayed many years. And so that left, we only had one market. And that was NASA or the few commercial space operators. Commercial space operators, like who did the geosynchronous satellites, they didn't need us because they only had one person in the control center anyway, because those things never did anything. They just sat there in geosynchronous orbit and they were like giant cell towers. There wasn't any operational, stuff that they had to worry about. But you're talking about space station. So when my partner at story time, I guess, but that's why we're here. My partner at now on our board of directors and on the management team, Bill Reedy, at the time was NASA director of space flight. John Young, his buddy, also an astronaut, who did the first shuttle flight, was now working on the space station. And he went to Bill and he said, "Beats 80,000 parameters. This is crazy. We got to do something to tame this complexity." And Bill Reedy knew me because we worked together in Space Command. He knew what I'd been doing in the commercial side. And he came to me and said, "Brian, we need to do you to do a proposal to use your technology to automated monitoring of all this stuff." Well, it went into the NASA. So I did an unsolicited proposal and went into the normal way, and it got lost in the bureaucracy. And it soon became evident that they didn't want to automate that because it would reduce the headcount and the whole team. And it's now they don't even make any bones about it. That 200 people in that control center in Houston they consider that kind of their crown jewel. They don't want that to go away. And the Air Force was the same way. I went out to the Air Force, they were doing a new GPS thing, and they asked us to come out and pitch, and we did. And the commanding general said, "This is fantastic practice. It's just what I want because it captures all the knowledge in the model, and we can bring in, new airmen to sit in the consoles, and we don't need so many, and fantastic." And I said, "Thank you." I was getting a little jaded at this point. And I said, "Thank you, General, but I don't think you can buy it." He goes, "What? I'm the general. It's my decision. I can buy it." I said, "Okay, yes, sir. Thank you. I'll look forward to your order." And 2 months later, when the actual solicitation came out for the new control center for GPS, it was bundled with the maintenance of the legacy IBM mainframes. The only possible people who could bid on that were Boeing and Lockheed. It was already wired for them. So the government wasn't able. Now today, NASA still feels that way about their control center. In fact, it's been said, and I don't mean to badmouth NASA. I love NASA and I love the people in it, but it's actually been put in writing that the reason they want to do the Lunar Gateway, which most people can't find any logical reason why we need a Lunar Gateway, they came out and said because that would give our 200 controllers in the space station mission control center something to do. So automation and cost reduction in those systems is not really a viable thing to happen. Now, commercial, if it's all commercial, or you're going to have commercial people who don't have, they're small and nimble, and they don't have, a invested staff and those people that they want to preserve. Yeah, we could help them. Of course, we could. We could have helped. I could have done that 20 years ago, 30 years ago. But certainly, we can do it with the system we have now. Way more capable of what we have now. Compared to what we did back in the days with Voltaire. I'm sorry, another long-winded answer, but it's complex. There's a lot of stuff going on here.
And it's all gold. So thank you for that. Um, this one should be fairly easy and fairly quick to answer, though, from another anonymous attendee. Are there any other projects that we know of that have tried to model the world the way that we are doing?
No, and there's two reasons why we're pretty confident they're not. The most compelling reason was when we get our first patent, and we, in that first core patent, we outlined the our basic approach. There was nothing like it out there, nothing. The idea in in has always been in AI that you are going to find a magic algorithm that's going to be able to create knowledge or spin world models out of raw data. So they've always looked for that. There's always got to be some stochastic algorithm or some magical thing that you press a button and it cranks away, and boom, you get knowledge and you get a model of the world. Well, it's never happened. We don't believe it's even feasible because there is no master algorithm. You have lots of little reasoning routines, but they have to be based on an existing external information structure, which is knowledge, which is that model. So, so the whole thrust of AI has not been in the direction we are. Our patent search found nothing. All these years later, we continue to look. We've just done another major patent effort, by the way. We have working with a great company called AIPI, which believes that they've combined a really crackerjack team of patent lawyers and technologists, and they are combing over our technology right now. And they just completed another big patent search for anything, knowing there's probably nothing that's directly impinges upon us or reflects us, but even something which may be remotely, like it, that somebody might be able to raise, or cause us trouble down the road. So they're building a big patent fence. Many, many more patents and disclosures will be filed shortly. So that's probably one great comfort. Now you say, well, do you know some secret lab somewhere in China or someplace? Well, maybe, if it's secret, but when they do come out, they won't be able to sell their products in our country because we got a patent, because they'd be violating our patents. But there's another reason, and I think it's really more profound and more comforting. And that is, if you look at the strange path that we took to get to where we were, what was amazingly different about the first AI in space back when I was on the Hubble was I didn't come in there because I had some theory about AI. I mean, I'd given it a lot of thought, but I wasn't trying to create AI. I wanted to solve a real problem, which is the operation of spacecraft. And that led me to a different path. That led me away from algorithms and looking at knowledge. I saw the problem immediately as how do we get the knowledge out of my head with all its intricacies, and somehow to a computer in a way that was doable and scalable. I mean, it's always possible to write it from a program if you wanted to have millions of lines of code. That wasn't practical. And it was also, you could do it if you wanted to have hundred thousands of rules, and that wasn't practical. But now we're modeling a whole world with a cognitive core built on 100 core concepts. So it is doable, vastly doable. So our approach is just so radically different. Everybody else has always been trying to emulate the human mind. They always seem, from the very first conference at Dartmouth in '56, they said the whole idea of AI is based on the conjecture that you can mimic and imitate features of natural human intelligence. That's not what we do. We found a way to synthesize, not to mimic human intelligence. We learn by what's going on in our mind, but it's all been the focus of, can we get this information structure, our knowledge, and can we synthesize a synthetic form? That's why we call it synthetic intelligence, by analogy with the synthetic diamond, which is a real diamond, but it's not a natural diamond. Everybody else is trying to mimic natural intelligence. We're not. We're trying to synthesize knowledge and information structure the way a synthetic diamond is a real diamond with the same crystal carbon lattice as a natural diamond, but not created in nature, but created in a lab. We have created synthetic knowledge in a lab. So we just so different. I 20 years ago, I used to go to conferences and see somebody must be doing something like this. It seems like It seemed like the obvious way to go. No, in 20 years since I started going to some of these, never found anything like it. And that was even before the world slid into the, stochastic machine learning neural network paradigm, which is so alien to what we do.
Let's go into some rapid fire questions right now. So the first one from Albert Huber is, when do you realistically expect the first New Sapiens product will go public?
You mean first product being released to public? I would say optimistically, maybe in 8 to 10 months, pessimistically, 18 months. Here's a caveat on that. It's important to get often the best strategy is to get a minimally viable product out there and start bringing in revenues, and then that cascades into making it easy to raise additional money and to raise more and more revenue. And then that makes the world finds out what you're doing, and that also opens the door to getting larger institutional. The typical thing for a startup like ours is you raise money on angels, and then eventually you get to institutional money and raise a lot more money on Series A and Series B with impressive. Yeah, with each one your value per share goes up largely. That's how small companies become quote unicorns with $1 billion market cap within a very short time. One strategy to do that as quickly as possible, get your first product to the market as quickly as possible, demonstrate that your stuff works and has customer appeal, and then you can go and through that thing. Now, there's another strategy that says, well, yeah, but if you don't need, if you've already brought in enough money that you're going full speed ahead on the technology, maybe hold off a little bit longer and not come up with a minimally viable product, but a product that will knock people's socks off. And maybe that will accelerate. So those are things that we can't predict. But I think we can be pretty confident now, but from where we are and in our talks with larger institutions that could write larger checks. Like I said, I intend to get 5 million by the end of the year, and then within the next year, maybe augment that with another 5 million for crowdfunding. And we still need more a year after that. But before that time, I think we'll be ready to go for the big money, which would raise our market cap to unicorn status. And if we have liquidity for existing shareholders when that happens, it's going to be a lot of smiling faces. So it's been a long road, but we really see the light at the end of the tunnel for our investors and our technology and the benefit we want to bring to the world.
Another rapid fire is from Barry. Are the publicized big names in AI aware of what we are doing?
Not to our knowledge. Somebody asked about a year and a half ago, what is the thing you really worry about most? And he said, well, that there's somebody out there doing something that's completely different than we are, and we don't know what it is. And the person interviewing said, do you know about one? And he just said, I am looking at one, but he wouldn't say what it was. It's what's called a black swan event for LLMs, a completely different technology, which is us, that will come and do what they do so far better that whole thing collapses.
The next rapid fire question is, where do you see New Sapiens going in the next 3 years? Do you want to position the company for acquisition, or would you want to promote your own AI solution?
Well, let me say that as CEO of New Sapiens, I'm dedicated to do what's the best for our shareholders, with the caveat that I wouldn't do something that was short-term good for our shareholders that was bad for the world. Okay. I think that I personally believe, and I'm certainly not alone in this, that the social damage and individual damage that LLMs have the potential for doing, and in fact are demonstrating to do, is very concerning. And I would never lead New Sapiens down that path. Our core values and on our board of directors and our employees is that we're going to bring a product to the world that's going to uplift individuals and society in a very positive way. We're not going to build something that's harmful. And that gives me pause. Because when we get our first products out there, when Tim Cook, just like Steve Jobs before him, when they first saw Siri, went out and made an offer and bought the company Siri Incorporated. When Tim Cook sees our Sapiens running on an iPhone and what it can do, I'm going to get a phone call. I'm not sure I don't know if it's good for humanity to sell out to Tim Cook. Um, Both because it may not be good to put this technology in the hands of our current big tech companies, which I don't know if any of us saw what was our one of our recent articles that we wrote posted that just the year before Google invented the transformer algorithm, or maybe it was the year after they invented the transformer algorithm, they dropped their long-standing motto, which was "Don't be evil." Kind of ironic, isn't it? So that gives me pause. But there's better and other ways of getting liquidity for investors that might be more lucrative as well. So 3 years from now, let me tell you what the expansion plan is, because I think this is pretty exciting. So if you look at Apple and Google and Microsoft, Facebook, I was there, I saw them grow up from little acorns, and I cheered them. I thought technology is this great. But they become these big, giant, stumbling bureaucratic things. Every time I use my Mac or my PC, I go, this thing feels like it was designed by a committee because was designed by a committee. Too many people. These companies have hundreds of thousands of employees. I've been in big organizations like Lockheed and at NASA, and big organizations become bureaucracies, and it dumbs people down. Even really good people with the best of intentions, even ones who are inspired to change the world in a positive way. But the giant organization really is inimical to that. I don't. So how's New Sapiens going to grow? Here's how we're going to do it. This is really cool. So we're going to start off when we have some funding. We'll start on one side we have our personal sapiens, companion sapiens, individual products for you and me. And then we'll have commercial lines of business like in space, healthcare, banking, customer service. And each one of those is a separate market. So what we'll do is say, okay, let's go after the customer service one. So we'll basically start a subsidiary company, which we operated independently. We'll bring in people who know all about customer service, who have the expert knowledge in their heads that we will put into their Sapiens products, and they'll go off and they'll take over that market. Or in space, same thing. Space. So we start off in space. But let's say the space company after 2 years is doing well, they're growing, they get up to, I don't know what the number might be, say 100 employees. When we get up to 100 employees, they'll divide into two companies, maybe one for ground systems and one for flight systems, or move into adjacent market drones. But we'll keep subdividing. So every, say, 2 to 3 years, as these companies grow to, say, the level of whatever the optimum number turns out to be, of a small, nimble company, really focused on their markets, all expert in that market. They know how to sell into it. They know how to solve its problems. Focus, focus, focus. So, but every 2 years, they double. For 3 years, they double. So that's powers of two every couple of years. So we don't end up with a company of, in 10 years or 15 years, of 100,000 employees. We end up with 1,000 companies of 100 employees. And all nimble and focused. So that's what I see. That's how I want New Sapiens to grow. And you can imagine the value to our shareholders because all of those companies were owned by the shareholders in New Sapiens. And after a while, as the money starts pouring in, we won't be selling our shares anymore. But the people who have shares can sell them and sell them each. But so that's the dilution stops. And that's why we don't have to go public. So we don't have to keep selling shares to the public. It's a cash cow. So the opportunity to invest in this company now is, again, a wonderful opportunity because you're investing in a company like Apple was just, had 15 employees, or Microsoft had 15 employees. If you bought their shares then, where would you be, 10, 15, 20 years later? It's a great opportunity, but it won't last forever because this thing's going to generate lots of cash and we won't keep selling the shares anymore.
Another question on this from Kevin O. In the first round of investing, a personal lifetime Sapiens was offered for large investors. Is that still available? And are we still fundraising offerings? And also, when is the next round of fundraising?
We have one going on right now, and Aish will tell you about that. What we offered was that if you were an existing investor, you would get first shot at beta testing. And we actually kind of pulled that off the table because we had to rehash, but the offer is still there. So yes, if you are an investor in New Sapiens, you will get uh, beta testing. Whether or not that will be, I don't remember whether we actually said it was be for a lifetime thing. Do you remember, Ayush? That's certainly a possibility. But certainly our existing investors will be our first customers and our first beta testers, and the beta tests will be free. And very likely we can extend that and make it lifetime. I don't want to commit to that because I don't know how it's going to shake down, but very possible because the number of investors we have is going to be infinitesimally small compared to the number of users we'll have down the road because that would go into the billions. So there's no reason why we wouldn't do that. But I will commit, though, that if people invest today, will have an opportunity to get a free beta test of Sapiens when we're ready to do that. And again, we weren't ready when we thought we would have been we had some training and we had some growth to do internally. So we weren't ready to do that kind of beta testing. But we do hope to get that going again, sometime in the next year. So you'll be the first to have Sapiens.
Another question from Ray Sunby. Thank you for being here, Ray. Thank you for your support. Can we talk about the trade-offs between using profits to grow and develop the tech and not dilute current shareholder value, and raising large sums with further funding and diluting current shareholder value?
Well, sure. I mean, one possibility is we get our Sapiens out there and we start, it goes viral and we start have all of a sudden we've got as many Sapiens users as Facebook has customers and they're all paying us, $12 a month. That's an incredibly staggering amount of money. Why would we mess with that? Why would we sell shares? But on the other hand, one of the things that happens when all the money starts chasing you is there's a demand for it, for your shares, that typically does exceed the amount of capital you want, which causes institutional investors to basically bid against each other, which drives the value of your shares up, which means that the existing shareholders' the value of their shares goes up and up and up as well. So the way that works is, yes, you get some dilution, but you get the dilution you get is infinitesimally small compared to the value of the shares you have. So what you end up getting is you get a slightly smaller piece of a vastly bigger pie. So your own pie piece, the net value of it is higher. So there's that kind of trade-off. And that's kind of been the more dominant thing. The other thing is if a year from now or 18 months from now, as I hope, that we can demonstrate that we've solved the problem and we can, because of all the money starts chasing us and demand for that, because we don't have to take that much money because our development costs are not anywhere in the ballpark of what LLMs cost. We got way more money chasing us than we need. So the share price goes up. And, if your valuation goes up over $1 billion and you raise $100 million, that's not a large thing. If it goes up to be $10 million, you're not getting that much dilution. Early on, you brought in a lot of institutional money when your share price was $1. The VCs quickly own the company, and everybody works for them. And I know what that's like. It doesn't really help. I hope I answered that question.
Another question is when will our value be recognized by the larger AI community?
I think that will happen when we get these first products out there. When a person can pick up their, a mobile device and start talking to it and really realize for the first time that device, that entity on that device truly understands what they're saying, tracks the topic of the conversation, even is able to make intelligent guesses about the speaker's state of mind. That is, why are you talking to me and what is it you want me to do for you? And guess correctly, follow the change in context. It's going to be stunning. And when that happens, the world will know that artificial general intelligence has been solved. And again, I think that can happen sometime. I expect it to happen. I plan for that to happen sometime in the next 2 years, if not, if not in the next year. Could be wrong, forward-looking statements and all that. But we're getting real traction now. It's very exciting. I mean, raising money in the past, it's been like, pushing a stone up a hill and watching it roll down again. You're always raising money. But if we can get some real traction this year, as I hope, with the current crowdfunding offering that's going right now, get some traction there, and that also allows us to move the state of the art forward and demonstrate to um, the sources of bigger capital, because a year, and able to double, triple our staff in the next year and still have plenty of runway there. That's game changing, and I'm ready for it.
I'm ready
Real.
too. There are so many applications of generative AI now. Do you think that New Sapiens will be able to catch up?
We believe that we will crush generative AI. In the end, there's nothing that it does. And let me propagate that, except for image generation. That's a whole different thing. We don't do that. I see generative AI I mean, there's obviously intellectual problems with image generation, but I see it as, kind of the next thing in animation technologies and virtual reality technologies, and that's going to go off and it's going to do its thing. Maybe that's what they're using these big data centers are doing for is virtual reality. That kind of makes sense, because when it comes to words and knowledge and information, that technology is so flawed where we are so right on spot, right on target. Yes, there'll be a day that you could ask a Sapiens to write a document for you. It would have absolutely no errors. It would be clear and elegant, and maybe even be able to articulate subtle clarity of ideas and thought, because Sapiens have thought. And they have great clarity of thought because in a sapiens mind, every idea is absolutely precisely defined, and the relationship between other ideas are precisely defined. It's none of that ambiguity and fogginess that I'm afraid that the human minds are prone to. So it will be an elegant and correct writer. Someday when we teach it programming expertise, yes, it could be that sapiens would be the best programmers in the world. However, and this is a thought that came to me recently, I don't think that human programmers will go away because human productivity and human inventiveness is great. But the other thing, people like to program, and people enjoy it as an art, and then they'll continue to do it. And so, if you want to be a programmer, you can still be a programmer, even though you know that maybe the Sapiens programmer could do it and have the time and just as well, but maybe not. Human creativity is quirky. So, I mean, if you love programming, having a Sapiens write your program for you is maybe like buying a robot and have it take your vacation for you because you're working too hard. You don't have time to take vacation. It's silly. So, so yes, it's a technology that is more seeming than real. We will. It's ironic, I think, when you look at OpenAI, big tech companies, they've created a desire and an expectation for AI that could do these things, but it doesn't really do them that well. We will do them well, and without the problems of giant data sets and giant energy consumption and inaccuracies and hallucinations and bias, which is built into that technology as well. You never get bias out of it. It's inherent because people have bias, and it summed all the people's words up, and it's going to reflect there's the basic bias of the people who wrote the data sets, whatever that might be. So we don't have any of that issue, none of it. So it's just a superior technology. It's real AI. It's the real thing. It's truly the holy grail of computing.
We want to make sure we respect everyone's time. So as we close out, we're just going to ask a couple of more questions to Bryant, and then we'll round off. Bryant, these last couple of questions revolve around climate change. How is New Sapiens contributing to that? Do we require all these massive data centers that OpenAI and Anthropic and Microsoft are building out? How are, what is our goal here? How are we contributing to the environment in all of this?
We will contribute to the environment by running GP, by doing what I just said, by driving LLMs out of the market. How much does the energy by Sapiens running on this phone consume? It's immeasurably small amount of energy. It's just not a thing. Nor do we have to have train it. We don't need data centers. We don't need our energy. Deploying our technology all over the world will only require a immeasurably small amount of energy because it's again so compact. And the inherent way it does things, it's compact and um, doesn't require a huge computational load. Stochastic algorithms, like trained things, are just energy hogs and computer hogs, processing hogs, are just huge, by huge amounts. So the best way we can directly affect the environment and sustainability is by running those energy hogs off the face of the planet. Um, with time, in terms of the other thing though, which as things go on, is this is the wonderful way to we curate knowledge from the best sources and we make it available in computers to help people solve problems. So if you're an environmental scientist and you have your environmental scientist sapiens plug in, you're going to be better at doing your job. We're going to enhance people's. If people have limited memory, they forget things, they have variable memories, they have limited intellectual capacities. Sapiens are amplifiers for that and connectors to that. You can get all the greatest climate scientists in the room with their sapiens talking to them in their rooms, and their sapiens have collectively can meld kind of into a super mind to work with them with all the knowledge available to them, all the computing power, all the connectivity, all the repeatability of the logic. And so I think that when we get to that stage, the sciences will take a great leap forward. Won't replace human scientists, but it will enhance and overcome the limitations of the human mind. You know, another way to look at it this way, traditionally when you are have a startup and you're raising money, they always give you kind of the format of things. What's the problem you're solving? You know, what's your solution? Da 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 da. What's the problem these sapiens is solving? The problem is the fundamental limitations of the human mind. That's the problem. We forget things. We can't stay in school forever. We can't, you know, the world is all integrated, all the sciences. We break them up in these stovepipes because we can only handle a little bit at a time because of the limitations of the mind. But really, there's kind of one universe and one master science. It's all connected to each other. Sapiens will be able to get their mechanical minds about that someday. It's quite inspiring.
Just as we close out, a message from the Reg CF. So we've achieved so much just through crowdfunding. We achieved Bloom's taxonomy level 3 in a machine for the first time ever. Not first time ever for our company, but the first time ever Bloom's taxonomy level 3 was achieved in a machine. A lot of things have happened with this company just through crowdfunding, and so we do ask for your support. We write articles weekly, we host webinars very frequently, and we are continuously making progress and making breakthroughs. And so the support means the world to us. It keeps us moving forward and make sure that we can hire more and more talent. And if you've seen what we've been writing about GPT-5, that is not a recent occurrence. We've been talking about that not even for months, but for years. And so you can see our track record of making these not predictions, but seeing through the hype, seeing the reality of what's taking place, and doing what we need to do in order to build it out. And so we do appreciate all of the support thus far, and we want to make sure that moving forward, the support stays there. And as we do that, we have one more thing from Bryant.
I'm sorry.
As a
Well,
as last words, if you want to close it out.
oh, well, you know, you said how much we appreciate your the investment, the support from our investors. I mean, they really do some, have made it possible and are going to make a difference in the world. But it also may be the incredibly good investment. Um, I mean, it has all the hallmarks of a great investment. So by all means, and that's why you can. And so we have a website. You can invest right on our website, right, Ayush?
Yep. So the investment website is investnow.newsapiens.com. If you encounter any issues, you can email us at ir@newsapiens.com or comm at newsapiens.com. We'll be more than happy to help you out, guide you through that if you have any questions or feedback about that. And thank you all so much for today's webinar. We always appreciate the support, appreciate the great questions, and we're very dedicated to making sure that GPT-5, as it gets to the plateau of productivity, that's not necessarily the plateau of productivity for humanity. We're right there. And as a last thing, we can allow Dr. Reedy, Commander Reedy, to say a couple of words.
Well, I think today's session was just outstanding. Brian, you elucidated on a number of things in greater detail than the previous version, and Ayush, thanks for being the moderator. I think you teed things up very, very eloquently. Um, I just like to say onward and upward. We're on the path to success, and I'm on board.
Thank you,
Thank,
Commander.
thank you, Reeds.
Thank you, Bryant. And thank you all for today. The recording will be sent out by Monday. Have a great weekend. And as Commander Reedy said, onward and upward. Thank you, everyone.